Hello, ladies and gentlemen, and today I'm going to be presenting semester 2 project structures, and I'm going to be talking about the Gateway Arc done by Omar Hassani in Salem 9B. The Gateway Arc. So, what is the Gateway Arc? So, the Gateway Arc is a monument in St. Louis, Missouri, that sits along the west side bank of the Mississippi River. The Gateway Arc is also considered to be one of the most iconic monuments in the US. And it actually takes its name from the city role as the gateway to the west during the expansion of the United States in the 19th century. Now I'm going to be talking about the design and the designer. So the arc was designed by the famous American architect Eero Saarinen in 1948. And it was actually constructed between 1963 and 1965. So the arc was to be constructed in a very elegant and strong shape, and it represented the door to the western part of the country. The arc was 630 feet and 192 meters, which was very tall, and the distance between its two legs is equal to the height. That's really amazing to be done from the architect. Also inside are two trams, and each tram consists of 8 cars that each carry up to 5 seated people at the time. So the ride in the tram would actually last for around 4 minutes, and at the top of the arc there was a viewing platform where people can see all of the US in a really amazing high view. Also 16 windows faced east and 16 windows faced west, and it showed all of the city, rivers and surrounding land. The view was actually amazing. And at the bottom of the arc, the Museum of Westward Expansion featured beautiful displays that showed what life was like in the 18th century. So you can see it from the arc at the top. As you can see, this is the picture of the arc, the Gateway Arc. And right now I'm going to put it on a coordinate plane. I chose to work with these points. I plugged in the points. I got the y-intercept, which is point C. It's 4.5. And I also chose these 2 points, which is B and D, to work with them as they are in on the positive far part of the coordinate plane, so it's going to be more easier. So also we knew that each block counts as 21.3 meters around, as the whole building is actually 192 meters. So I calculated each block, it's 9 blocks, the height of the building. I divided them by 192 to get each block how much it counts, or the scale of the whole graph. So right now we're going to be working with point B, and we're going also to be isolating point B or B in the equation to work with. So our first thing, the equation is y equals ax squared plus bx squared plus c. And as you can see on the right picture, there's a picture that states that label B, or point B is 1, 4, which means that the y is equals to 4 and the x is equals to 1. So when we calculate it, it comes out that we're isolating alone the B to let it stand on its own. And finally, so B is equals to negative 0.5 minus A. So this is the coordinate B for point B. Right now I'm going to be getting B for point D. So I'm going to be repeating all I did and isolating B, so I can get the point, and it's actually the point B in the B in point D is negative 1.25 minus 2A. Then I will say that B equals B, so I can get the A. So actually the B of the first one, the B of point B, and the B of point D. So it's going to be negative 0.5 minus A equals negative 1.25 minus 2A, which means that A equals 0.75. Then I'm going to be saying that B minus 0.5 minus 0.75 is 0.25. And then I'm going to be saying the final equation, which is y minus 0.75 x squared plus 0.25 x plus 4.5. And our parabola is a downwards parabola, so the A has to be negative as it is. So it's going to be 0.75 x squared. Then my final quadratic function is y equals negative 0.75 x squared plus 0.25 x plus 4.5. And also for just checking and double checking my answer, I'm going to plug any point that I didn't use, like point A, which is x minus 1 and y4. And then I'm going to replace them to give me 0 equals 0. Last but not least, these are some fun facts or examples of arcs I visited around the world. So the first one is Arc de Triomphe, found in Paris, and it's shaped as a downward arc. Last but not least is the Eiffel Tower that I visited in Paris. It was a huge and beautiful tower, and its arc was at its bottom. It was a downward arc. Thank you for watching and listening.